We're talking about Chapter 5, Section 2, Bisectors of Triangles. Your objective is to prove and apply properties of perpendicular bisectors of a triangle and to prove and apply properties of an angle bisector of a triangle. I want you to pause the video and take a look at your DOK chart so that you can write your essential questions and then come back. First, we have to learn a few vocab words. When you have lines that intersect at one point, so lines that cross at one point, that point where they cross is their point of concurrency. So these lines are concurrent at that spot. That is their point of concurrency. And you also have the circumcenter of a triangle, and we're going to talk about that over here when we talk about the circumcenter theorem. So if I have lines, well, if I have a triangle first, and then I draw in lines that are perpendicular, so those lines cross each side at a 90-degree angle, so this line is going through this side at a 90-degree angle, and it's the bisector, so these two sides are cut in half. If I do that 2 more times on every single side of my triangle, so now I take a look, this is the side, I'm cutting it in half at a 90-degree angle, so both of these sides are the same, and now I'm taking this side, I'm going to cut it in half at a 90-degree angle. This place where they all cross is called your circumcenter. When this happens, or when you have this as part of your proof, you are allowed to conclude that PA, this segment here, I don't know if you're going to be able to see that, PB, this one here that goes through the angle, and PC, this one here that goes through the angle, are all the same. Sometimes your circumcenter is inside the triangle. There's your 90, there's your 90, and there's your 90. Sometimes it's on the outside of your triangle. So here's my 90, here's my 90, and here's my 90. And then sometimes it's right on the edge right there. There's my 90 degree, there's my 90 degree, and here's my 90 degree. If it's acute, it's always on the inside. If it's obtuse, it's always on the outside. And if it's right, it's always right on that hypotenuse. Now I'm talking about circumscribed. The theorem that we were just talking about right here, the circumcenter theorem, this finds the center of the circle that I would be drawing around my triangle. So if we go back to the other page, if I draw a circle.
Sarah RC, please call the high school office. Sarah RC, high school.
Sorry, I'm still at work. If I draw a circle around here, or pretend my circle's better than it really is. Pretend that that's a circle. This point right here is going to be the center of my circle that I draw around my triangle. So this is going to be the middle. That's what circumscribed means. So circumscribed is the circle that's around, but it touches at all the corners right there. Alright, so your first example. I have this triangle here with those portions labeled, and I know that DG, EG, and FG are perpendicular bisectors. Whoops. So these segments here are perpendicular bisectors. Are all perpendicular. This is the same as this. This side is the same as this one. And that one is the same as that one. I need to find GC. So GC, this one right here. This segment. Now because all of these are perpendicular bisectors, I can conclude that G is the circumcenter. Is the circumcenter of this triangle, and I know that using the circumcenter theorem. So by using the circumcenter theorem, I know that this is the circumcenter. Now that I know it's the circumcenter, I know that GC is equal to GB. GC is the same as GB. Because GB is 13.4, I can substitute that in, and that gives me that GC is 13.4, which is what I was trying to find. I have this one started for you. They wanted you to find the circumcenter of triangle HJK, and then they gave you the vertices. So the first thing that you would do is graph the triangle. H is at 0, 0, so this is point H. J is at 10, 0, so here's J. And K is at 0, 6, so this is K out there. After you graph your triangle, you're going to want to find the perpendicular bisectors of each one of these sides, or at the very least of two sides. Because if two of them cross, then you know the third one's also going to cross through that same side. To find the circumcenter. And what you would do is find the center of this, so you can use midpoint theorem. For now, since I want to get through the video pretty quickly, I'm going to eyeball it. Halfway between 10 and 0 is 5. And then I'm going to make sure to draw a perpendicular line going through that point. And then same thing with this one. So halfway between 0 and 6 is going to be 3. And through that midpoint, I'm going to draw a perpendicular line. This spot where they cross is going to be my circumcenter. So I have a circumcenter at 5, 3. Whoops. At 5, 3. Now I was going to write the word circumcenter. Here's another theorem. It's similar to the last one, but we're going backwards now. The other one was talking about perpendicular to the sides. Now we're talking about the angles. So this one's called the in-center theorem. The one we were just talking about is the circumcenter. This one's the in-center. If all of your angles are bisected, so these are all cut in half, then the spot where those lines meet is going to be the same distance to each one of the sides. From that point to each of the sides is the same distance. The other one that we were talking about said that that point, that center point, whatever it was that we created, was the same distance to each one of the angles. So now we're saying that this point is the same distance to each side. When we were talking about the circumcenter, we said that depending on what type of triangle, it might be either inside, on the outside, or right on the hypotenuse. For in-center, it's always going to be inside your triangle. So this is what it's going to look like for an acute triangle, for an obtuse triangle, and for a right triangle, because you're cutting your angles in half every time. And that's always going to end up on the inside. When we're talking about the in-center, we're talking about a circle that's inscribed in your polygon. So if I cut all of these angles in half, it's not going to find the center of a circle that I would draw around my triangle. It's going to find the center of a circle that I would draw inside my triangle. The circumcenter found the center of a circle that I would draw on the outside of my triangle using all the vertices. All right, next example, we have MP and LP. MP and LP are angle bisectors, so these two are the same, and these two are the same. Of this triangle, find the distance from P to MN. P to MN. When we're talking about distance, we're always talking about the shortest distance between that point and that line. So that's going to be a perpendicular line, because that's going to be the shortest distance. Knowing that these two lines are bisecting it, I can use the in-center, or I can say that P is the in-center of triangle LMN, and that's using the in-center theorem. In-center theorem. And because of this theorem, I can conclude that the distance PQ is going to be the same as the distance I don't really have a point for that. We're going to call it PQ, we're going to call it R. So PQ is going to be equal to PR, and PQ is 5. So this line from P to MN, which I called PR, is also going to be 5. Last one. MP and LP are still angle bisectors, so this is congruent to that, and that one is congruent to this one. Find the measure of angle PMN. PMN. So we want this angle here. I can say that measure of angle MLN is going to be 2 times the measure of PLN, and that's because this is the bisector, and they told us that here. So the measure of angle MLN is equal to 2 times the measure of angle PLN, and I know that PLN is 50. So 2 times 50 gives me the measure of MLN. The 2 times 50 gives me 100 degrees. So the measure of angle MLN is 100. And after I find that out, I know that all the angles in the triangle will add up to 180. Now I'm going to use just that capital letter to talk about the whole angle. So the measure of angle M plus the measure of angle L plus the measure of angle N equals 180. We know the measure of angle L, we just found that one, MLN is 100. We know the measure of angle N is 20. That's going to equal 180. And we're still looking for the measure of angle M. So 100 plus 20 gives me 120. If I subtract 120 from both sides, I'm going to get the measure of angle M is equal to 60. And I know that PMN, which is the one that I was looking for, measure of angle PMN, is half of this entire measure of angle N. So the measure of angle PMN is half of 60, which gives me 30 degrees, and that's what I was looking for. Don't forget to write your summary and your any extra questions that you have beneath your summary. Watch the video again, because I know that circumcenters and incenters and are confusing, and I think it's important that you review. So watch the video one more time. Don't forget to write down your questions, and we'll talk more about this tomorrow.